Again, a contour map is just drawing several level sets. It's important to label each level set for which output it corresponds to. Otherwise, you just have a bunch of different drawings on the same set of axes, and it's not clear what's going on. I mean, colors are helpful, but even if you just took each of the level sets and you wrote like next to the level set k equals this number, k equals that, that would work, right? So, question: how do the contour maps for f of x comma y equals x squared plus y squared and g of x comma y equals root x squared plus y squared differ? Um, Notice that the contour map for f is concentric circles. Pick k to be a perfect square to see, right? Like if you pick k to be 25, you've got 25 equals x squared plus y squared, and isn't that a circle of radius 5? The contour map for g is also concentric circles. Pick a number, right? So pick a number like 7 as the output for g. So replace g of x comma y with a 7. Then you have 7 equals root x squared plus y squared. So then you square both sides and you get 49 equals x squared plus y squared. And that would be a circle of radius 7 centered at 0, 0. So here's the thing. Consecutive integer radius circles for f have k values which are consecutive perfect squares, while consecutive integer radius circles for the function g have k values which are consecutive integers. That's a lot to chew on, but think about that carefully. Draw, um, literally go through the process here on your own. Try it. Replace where it says f of x comma y with a fixed number. Replace where it says g of x comma y with a fixed number. And then make sense of these two items in the bulleted list. Okay, just to really try to bring things home and to help this make sense a little bit, you might appreciate this analogy if you're a hiker, but whether you are or not, I'd like you to try to take this in. A topo map or topographic map is a special map which shows all locations of the same altitude or height. Here's an example. Let's click on this. Okay, the example we are going to look at happens to be the bluffs that are just east of La Crosse. Okay, so here we go. Just east of La Crosse, right? So let's see, there's campus, right? And the bluffs are a great example of lots of different heights going on, right? So think about like the function where let's say the x coordinate is latitude and y coordinate is longitude, or I might have switched which should be which, so forgive me there. And then the z coordinate is literally the height, like the altitude, like how far above sea level in feet or something, right? That's what this is trying to show. So, like somewhere just east of Losey Boulevard or State Road 16, you're seeing like this line that has a 900 written on it. Sorry, I didn't check all the units for what's going on. I assume this is 900 feet above sea level, but all of these points here are, have a z coordinate 900, right? So for the literally the function where x and y represent latitude, longitude, and the z coordinate represents the altitude, uh, this this is a level curve. This is, and it's really the level curve representing height. So you can imagine that literally the surface of the Earth, say here in La Crosse, represents the graph of a function, right? Don't look at the dirt underneath. It's just right at the moment where the ground hits the air. That creates the graph of a function that passes the vertical line test, and all of the places that are exactly 900 feet above sea level are depicted like along this tan line here. Okay, so as we were explaining, we're considering really the function. There is a function, which has two inputs, latitude and longitude, and the output is the altitude. And one of these curves on the topo map, like we saw with that 900, it's a level set. And so when you put all of those level sets together, as you saw in this picture, what you're getting is really a sense of what the terrain looks like, right? You really somehow in this little 2D picture with all these separate lines that are, they're spaced apart, sure, right? But like this is giving you a sense of, even without this shading, the shadow-like look, like just the lines themselves would really give you just a sense of what the terrain looks like. And once you're kind of around campus, it's not all that hilly anymore. So somewhere here, I bet there's a line drawn somewhere in town. Maybe, I don't know. Maybe kind of up here where the train track is. There might be. Yeah, I should have maybe looked at this before. Oh, like here, right? So there's finally an altitude shift that occurred. Looks like here there's like Zooming in, just south of I-90 up in on Alaska, there's this little circle. Oh, cool. I zoomed in and it says 700, right? I didn't know whether this was a little dip, like where rain might collect, or if this was a hill. And just looking at the 680 versus the 700, that's got to be a hill. But see, I have a sense of there's a little hill. And then actually the peak over here, I'm guessing, I mean, I'd have to get more data, but my assumption would be that the hill is like, 710, or I don't know if 680 is here and there's this much distance. Maybe there's only like 702 right at the top somewhere in here. But this 2D picture with these lines drawn in really gives us a rich 3D like picture just due to all of these curves being drawn in here. And this collection of all of these curves are level curves or level sets. These things together create a contour map, and that gives us a good picture of what the terrain, you kind of get a sense of the entire landscape by doing this. Let's look at another example, an isothermal map. This is a map where the level curves now tell you places that all have the same temperature. Okay, so in this example, let's see, pink, well, okay, there's no pink here. Let's try again. How about like, th this teal versus this sort of seafoam green? What's going on there? So I guess this kind of greener color represents temperatures between 30 and 40, and the teal represents temperatures between 20 and 30. So right at that border of the teal and this slight green color, that would be exactly 30 degrees, right? So that means right along here, so this was the temperature back in 2001, and I guess it's an average temperature, but let's just pretend it was a specific day in 2001. All along this curve right here, where the two colors meet, this is a depiction of all of the places in the continental US where back, some decades ago, the temperature was 30 degrees all along here, right? And so that could be, if we had a graph of, again, latitude, longitude would be your X and Y inputs, and your output Z would be temperature, or temperature on one day in 2001, this you can see that this three-dimensional data depicted in a two-dimensional drawing, because all of these points had a z coordinate of 30, and then all of these points had a z coordinate of 20, or whatever, right? So we get, maybe I should move the other direction towards the south. All of these points have a z coordinate of 40, and all these points have a z coordinate of 50, and so on. So we see in a 2D picture, by having lots of separate level curves or level sets drawn, we can lift this information into a three-dimensional picture. Okay, so for instance, the curve where the yellow meets the lime represents 60 degrees, right? So yeah, the yellow meets the lime here. All of these places right along here, those are places 60 degrees on that specific week in the year 2001. This is a set of locations in the US where the average temp was 60 degrees. This is one level set in the function with two inputs. And the output is the average temperature. So this idea that if we go back here and lifted all of these points 60 units up towards us, and all of these points over here, we only lifted, what was it, 20? I forget now. 30? Yeah, 30 units above, right? So that would give us this nice 3D picture where these points over here are lifted higher and they're closer to us because the z-axis is positive, z-axis is pointing towards us. Let's see a level set for the function f of x comma y equals sine of x plus sine of y. Now, by default, what's going to be shown is the level set for k equals 1. That is, what x comma y's are going to have an output of 1. But you can change the value of k to see what happens. And so let's give that a try. Okay, here we go. This looks a little surprising, but literally all of the points in the xy plane where f or sine of x plus sine of y, better known as f of x comma y, is equal to 1, looks like this. And then you can change the values to see, oh, that was kind of fun. When k equals 0, what are we talking about? So this is a graph of all of the places where sine of x equals negative sine of y. This is kind of fun. I don't know. And then, The other thing you might find a little odd is that at a certain moment, you pick k to be too big, and you're not going to see anything. And that's because, well, each term, sine of x, sine of y, can only range between -1 and 1. So when you get beyond 2, you can't have anything. I'm actually, well, yeah, I guess when you have the number 2 itself, you couldn't either due to, well, I don't know, maybe you should have something, but the computers may be struggling to get, this might not be quite perfectly accurate, right? These are probably not perfect circles because these are clearly not quite, right? So I don't know. This is kind of fun to take a look at, I guess. But yeah, for quite a number of values of k, or quite a number of desired outputs, you don't have any combination of inputs that gets you there. So for instance, um, here we're looking at the level set for negative zero point 0.2, meaning right here, oh, can I get this point? The computer's not going to be nice. But like when x is 6 and I guess y is 6 point something, the z coordinate should be negative zero point 0.2. Right, so by default we saw when you first load the web page, you get the level set for k equals 1, but you can change what output you'd like to look at. So I'd ask you to please click on this YouTube video that I created. It is a physical demo. It's about a minute long. And what I have done in this video is I've taken a soap mold. Right? This is a thing in an arts and crafts store that's a plastic template. If you kind of create your own soap mix, you just store it in here in the right direction, and then it will solidify, I guess, to create soaps that have really neat, intricate designs on them. But if you hold this plastic thingy in the right way, the entire plastic sheet itself satisfies the vertical line test. And so you could just interpret that as being the graph of a function. And then on it, what I tried to do is I just tried to leave this level on my office desk, and using a Sharpie, a red Sharpie, I tried to mark all of the points on this plastic that were literally the same height off of the ground, or same height off of the surface of my office desk. So these should all be points of the same z value, and that would create one level set.